Whether you are developing biotherapeutics or drugs for the treatment of cancer and other diseases, you're likely to need encapsulation of your API or biotherapeutic in lipid nanoparticles. Lipid nanoparticles are an attractive vehicle for encapsulation and delivery as they are small in size, made up of phospholipid membranes that resemble the lipid bilayer in the human body. This means they can easily penetrate and target a specific site for the delivery of your biotherapeutic or API. Formulation of your lipid nanoparticles is an essential step in the development of your therapeutic. There are no off-the-shelf solutions to formulate your bioactive into these lipid nanoparticles. Significant development and optimization is required to formulate a delivery vehicle. Traditional methods, such as homogenization and thin film hydration, are laborious, produce polydispersed lipid nanoparticles with low encapsulation efficiency, and require large volumes. With microfluidic technology, you can overcome these issues and produce lipid nanoparticles which are monodispersed, reproducible, have high encapsulation efficiency, and use low reagent volumes. Our modular system allows the user to have flexibility in their experimental setup. It is comprised of two pod pumps which hold two pairs of syringes that aspirate and dispense your driving fluid held in the pressurized input store, in this case in these bottles. The driving fluids prime the fluidic pathway, including the sample loops in the automated sample valve, and droplet chips, finally, the automated collector. When running your protocol, the software prompts you to load your nanoparticle precursors. This occurs here at the ASV via two different syringes. You can see here 1 and 2 that fit into this lure fitting. When running repeats, you will load the total amount of your NP precursor, nanoparticle precursor, required for all your repeats. The automated sample valve will gate your repeats in the sample loop, only releasing enough NP precursor to run one repeat at a time. Between each repeat, the system automatically washes the fluidic pathway with your driving fluid to ensure no residue from the previous experiment is present. You can choose your driving fluid depending on your formulation. In this case, I'm using PDS. During the run, the automated sample valve releases the defined volume of your NP precursor from each loop. So here we've got the sample loops to convert into the droplet chip junction, and you can choose up to 3 different chip geometries to create your lipid nanoparticles, each one having a specific benefit. If you want to find out more, please visit our Dolomite Microfluidics website. Once the two fluids have converged in the first chip, downstream a T-junction chip allows a further dilution of your sample. This is optional and you may choose to skip this step. Your fluid packet then travels to the automated collector where the automated valve allows the collection of your sample in 1 ml vials. The type of rack can also be altered according to your desired collected sample volumes. This includes using a 96 well plate. Our Flow Control Center allows easy, user-friendly control of your hardware. You can navigate to our Devices tab, where you will find individual windows showing each of the devices connected. You can see the software recognizes 4 syringe pairs, 2 on each pod pump, 1 ASV, and 1 automated collector. Each component can be controlled separately by the user in manual mode by clicking on any of these functions. Next, we are going to move to the Protocols tab. Here you will find the apparatus window showing the devices corresponding to the function required. You can select the device from the drop-down menu. The name of the device is dictated by your assigned label in the Devices tab. In the Parameters window, you can see that the user has the option to dilute their sample, and you can select either yes or no. The wash rate is the flow rate you want to use to wash the system in between experiments. The next 4 inputs are your volumes of the critical fluidic pathway, which allows the system to automate your sample, convergence, and collection. The experimental table allows you to have full control over how you want to run your experiment. You can choose your flow rates for each NP precursor and the dilution step. You can define the volume of your NP precursor 1, and based on the flow rate ratio dictated by the flow rates in the system, the system automatically calculates the volume required for NP precursor 2 and the dilution. The head and tail cut allow further precision of your collected sample by allowing you to collect a hard cut of the sample by removing the front and the back end of your fluid packet during collection. The output dialog box on the right here communicates to you what the system is doing at each stage, and this is automatically logged in your log file found in the Logs tab. You can carry out an isolated wash cycle here or simply begin your experiment by clicking on Start. When the system has finished priming and is ready for you to load your sample in the ASV, it will prompt you with a pop-up on screen telling you the volume required for each loop. Your total execution time can also be monitored at the top. Once your NP precursors are loaded, you can simply walk away and let the system collect your samples for you.